Okay, so I'll go ahead and get started now. Welcome to the AWS Cloud Security User Group. We're really glad to have you today. I'm pretty excited because we just hit 1,500 members last month, so that was pretty exciting. We've had lots of meetups as well, so that's even more exciting. We have our other co-organizer here as well, so if you can't reach me, you can reach him as well with any questions or concerns. With this group, the aim is to kind of provide a good and safe space where we can be productive in learning and growing as professionals, even if you're new to the IT industry, and just really talk about cloud security, specifically within AWS. But we don't mind also kind of having the generalized talks as well. So these are some topics that we have been trying to get through in the last year. We are still looking to get some speakers on these topics, and if there's anything, even if there's stuff that's not on here that you think you'd want to share with our community, definitely reach out to me via Meetup, or I'm going to be putting my LinkedIn later in the chat as well. And even if it's just a story of being in the industry or something you learned that you'd like to share with the rest of us, you know, we're all for it. We are looking for extra speakers at the moment. I always like sharing this, the shared responsibility model, just because it really shows that, you know, AWS is responsible for the security of the cloud, and we're, as users and as people who work with Amazon, are responsible for everything above the dotted line, and really getting familiar with that. There's a whole bunch of other models too, but this one's nice and simple. Okay, and we have lots of upcoming events, not just from our group. We have tomorrow, we have the AWS user group, the Midwest Community Day. It's something that I was trying to get hopefully to you guys this year in the Mid-Atlantic region, but we're probably going to be postponing that until next year. But tomorrow there is going to be the Community Day for the Midwest, and a lot of it is really good talks, really good presentations, and it's all led by the community. This Friday, the other AWS security group, the official one of, not the user group, but the one that AWS runs, they're doing an AWS virtual tech talk. I'm excited about going myself, just because they haven't had one, I think, since before this meetup started, since like early last year. So it's going to be hopefully exciting. June 13th, we have, just for career confidence, if you're interested in getting into cybersecurity, it's a really good resource to kind of go to and learn more about what you could do to get into the industry and break through. And then June 30th, AWS reached out to us to share the public sector summit online registration. So since that's now moved virtually, it's also free. So, definitely attend. It's a free resource, from AWS to learn. And then and then this is the community day. And I was going to, thank you for coming. And then just our code of conduct, just be nice, respect each other, and if you see something, say something. And I was gonna mention one more thing, if this can, there you go. This is something new I just found out about, like maybe 30 minutes before or ago. AWS is helping host the AWS Community Voices on AWS Twitch. They're having it live, and it's new. It's a 2-hour series which features community leaders, and I'm going to be hopefully posting this up on the forum, on the Meetup forum. I thought it was really cool to see. And with that, someone's playing piano and they're doing pretty good. Okay, so, and with that, I'll go ahead and hand it over to Drew, who's going to be talking about Fugue. Fugue is helping us with virtualization logistics, and being able to have us here on Zoom. They're also hopefully going to be having cute little prizes throughout the event, so that'll be fun, something to look forward to. And at the end, we're also, thanks to AWS, we're going to be giving away some free promos, AWS credits to use resources and stuff. And I'll be doing that at the end. And go ahead. Or Josh, I'm not sure if you were going to do it, or Drew.
Yeah, I was just going to do a quick.
Okay.
Thanks, Sarah. Yeah, just a quick kind of Fugue thing. I'm going to share my screen. This isn't actually about Fugue, but wanted to let everybody know we've kind of launched a cloud security masterclass series. These are kind of really fun, engaging, deep dives into various cloud security topics. Josh, who you'll see in a few minutes, who's going to talk about OPA, leads these. They're really fun. They're engaging. They're kind of hands-on. At least his hands-on. It's not a workshop, but it's not kind of your typical sort of slideware webinar. Definitely check it out. They're really not about kind of how-tos, more about how to think about these concepts, so you can kind of reason about your particular use cases on cloud, and specifically AWS, and do a good job on security. So I'm here with Fugue, one of the co-founders, and at Fugue, we believe that developers and cloud engineers own the security and compliance of their cloud environments, whether they realize it or not. And we believe that if you do recognize that you truly own the security and compliance of your cloud, your life's actually going to be a lot easier, and you're ultimately going to be able to focus a lot more time on the things that you really want to be working on, rather than all the audits and reporting and all of that kind of stuff that can kind of bog us all down. So what Fugue is, it's a software as a service product. It works on for multiple clouds, AWS, Azure, etc. And what Fugue is all about is empowering you, the developer, cloud engineer, security engineer, to really kind of take command of security and compliance, prove compliance at any time, understand your posture at any time, especially if you have really kind of always changing, highly dynamic, complex environments. There's a couple kind of primary use cases with Fugue, and they generally kind of go in the same order with our customers. The first is really just about discovery, visualization, and posture reporting. Within a few minutes of using Fugue, Fugue is going to essentially gather up all the data of your cloud infrastructure environment, all the resources you have running, how they're configured, how they relate to each other. And it's going to map that for you and give you a dynamic diagram of your environment. So you can kind of zoom out, see the big picture, zoom in, understand various configuration details, map all of that infrastructure against any number of out-of-the-box compliance standards like HIPAA, SOC 2, NIST, PCI, etc. And then get information back on where you have violations, as well as what you need to do to remediate those and bring those into compliance. And also just set up easy compliance reports that you can automate and get those out to management or auditors or whoever needs to get those. The second use case is really around kind of configuration change control. As we said, you did that audit, you kind of figured out what your compliance posture is, you remediated things, you brought it into compliance, but we're changing our cloud infrastructure all the time. So you need to understand that change as it happens. Did those changes cause some misconfiguration vulnerabilities or policy violations? And if so, what do you need to do to fix them? And so Fugue kind of then helps you continue to make sure that as you are operating on cloud, you're doing so in a secure and compliant way. The third use case is really about shifting left. We talk a lot about shifting left. Usually out there, it's around kind of application security. Fugue enables you to shift left on the cloud security aspect of your software development lifecycle. And that means kind of integrating policy checks into your CI/CD pipeline. It means giving your developers an easy way to kind of validate their dev environments so they can fix problems early before they get more expensive and we get into those costly rewrites when things get kind of rejected when we think we're ready to go to production. And we have tooling as well to use OPA, which Josh is going to talk about, not only to create custom policies for your cloud infrastructure, in addition to those out-of-the-box standards, but also use those same policies to validate your infrastructure's code file. So if you're using like Terraform, you can run these policy checks against your Terraform files, make those corrections as well, and get those good. So it's really all about not only just getting compliant, getting secure, being able to prove compliance at any time, but also just doing that in a way that kind of minimizes the headaches and just allows us to move fast. Fourth use case is really about self-healing infrastructure. This is sort of Fugue's take on automated remediation that doesn't require any kind of lambdas or automation scripts that trigger actions and remediation steps when things get out of how you want them. It's really about essentially establishing a baseline for your security critical infrastructure resources. These are the things that under no circumstance should they ever change, at least not without some sort of controlled change control process. And if anything there changes, because Fugue understands the full state of your infrastructure, it can change it back to what it was. So you can kind of get ahead of the bad guys that are using automation, correct things when they change and shouldn't, but do so in a safe way that doesn't cause the kinds of inadvertent destructive changes that can kind of take your application down. So that's Fugue in a nutshell. There is a free version of Fugue called Fugue Developer for individual engineers. You can find that actually at www.fugue.co/go. And again, it takes about 15 minutes to get up and running and get a great visualization diagram of your infrastructure and validate it against any number of compliance standards. And do check out the upcoming masterclass on IAM. You can see the URL there, and I think Sylvia is going to probably post that in the chat if she hasn't already. Thanks, Sarah and everybody, for coming out and having us out. This is always an awesome time.
Awesome. Thank you. Sorry about that. No, thank you guys. Thank you so much, for all the useful links as well, Sylvia. And we are ready to kick it off. So Josh, whenever you're ready.
All right, I am ready. I love talking to this group, and this is our second time virtually doing so, and it's a lot of fun. There's always good turnout, and I have to tell you, so we do something, and I'm about to start it tonight, where I'll put up Zoom backgrounds of stuff from kind of neat nerd geek culture, and then if you guess the correct answer, if you know what it is, and you put in the chat what it is, it might be tonight we're going to do kind of mostly anime and science fiction, but also some computer history and a little bit of gaming. If you're the first person to name what the thing is I've put up in my background, we understand that you're used to going to events and getting swag, and that's not happening. So we'll send you some cool swag. So here's the rule though. If you win one, you've got to stop, because you can't win twice, and it's going in the chat. So once you've won, don't guess anymore unless we open it up to everyone, which we probably won't. So I'm going to start tonight. What should we start with? Let's start with something from anime. All right, so I've got a background up here. And you've got to say what is this anime? I'm kind of blocking it. Let me shimmy off to the side here. All right, I think
Brent wins.
Brent wins. It's called FLCL, or Fooly Cooly. It is a exceedingly unusual anime, and really, really cool. As somebody who's been an artist all my life, this one I highly recommend. Okay, I'm going to share my screen, and we'll go into some slides. Now tonight, if you joined us for the last presentation, I was actually typing at a terminal. I'm not really going to be doing that tonight. I will be showing some code. If you don't write code, don't worry about it. It's no problem. I will be explaining what I'm showing. But tonight is really about an overview of a technology that we use at Fugue, and we facilitate our users to use of our product. But this isn't all about Fugue. This is about Open Policy Agent. And I am super excited about it for quite a few reasons. Maybe the main one being that I've been doing policy as code type stuff for years. Fugue has a bunch of fundamental patents on it. But for the first time, I think that there's now a potential industry standard, and it actually works and is good and is thoughtful. So I'm going to try to sell you, not on Fugue, but on Open Policy Agent, and at least explain it to you. So policy as code for all the things is the theme of the talk. Oh, I see here people are enjoying the screens, and somebody said, we ripped that from you and did our games like that too. Awesome.
Sure
awesome.
did.
Yep.
Sure did. It was great.
Right on.
Hey, it's patented and copyrighted.
Yeah. Well, that's something OPA isn't, right? OPA's open source and is now Cloud Native Computing Foundation. I won't say standard. It's not a formal standard, but it is one of their incubation projects. So the agenda for tonight, this might be redundant for those of you who have seen us present before, but I am going to give you an overview of misconfiguration risk in the cloud era, just because that's what we do with OPA. Why policy as code is so critically important. We say here mandatory. That's our view. We think everyone should be doing it because without it, you're exposing yourself to a lot of risk. We're going to go through an intro to OPA, and I'm going to show you some websites that will, let you keep going from here on how to use OPA, and a little bit of a deep dive into the OPA toolbox for cloud security. We have a ton of expertise with OPA because we've built a ton with it, so I'm going to drill into that a little bit, and then some getting started. Okay. So cloud misconfiguration risk. It says here a major security risk. It is the main security risk in cloud. According to Gartner, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. I like and I don't like this quote because, while it's true, it sounds kind of pejorative. It sounds kind of accusatory. And this is all that I and we as a company have been working on for years, and I'm here to tell you it's really hard to get right. So and almost no one, no one's really perfect. But it is true. And when we surveyed hundreds of users of cloud at scale, 93% said to us in that survey that they were concerned for a major security event due to cloud misconfigurations. When we asked them what kinds of misconfigurations, 2/3 said identity and access management. More than half said security group or firewall rules. About half said object storage, and then encryption in transit. And the awesome thing about OPA is it can address all of these. And actually in Fugue, we've built rules for all of these out of the box. So when you're thinking about catching whether you're making these misconfigurations, OPA is an awesome way to do that. The misconfigurations are often overlooked, and this is due to a number of things. Most security teams aren't aware of what the kind of list of dangerous misconfigurations are. And security teams tend to operate from, known information about what's unsafe and what's safe. And why don't they know what's unsafe? A lot of it is because the compliance frameworks out there, CIS benchmark, NIST, HIPAA, GDPR, I mean, we cover all these. They miss a ton of stuff that is actually dangerous in cloud. And therefore, the security teams aren't aware that those things are dangerous, and therefore, these misconfigurations are extremely commonplace in enterprise cloud environments. So a little bit about hacker strategy. And I know some of you who've watched us give this presentation before, this is probably redundant, but for those new folks who haven't seen us present before, I'm going to go ahead and really spend the time to explain these things. So in the old days, the bad guys would do kind of what the Hollywood version of bad guys do. They would target an organization. They would try to find ways into that organization and then exploit them. Now, this does still happen. And, two examples that come to mind are when Sony Pictures made a movie that the North Korean government did not appreciate, they were targeted and they were breached. Similarly, unknown actors in the world decided that they did not prefer for Iran to have nuclear weapons, and so Stuxnet was developed very specifically targeting that. Now, depending on the organization you're in, this is probably not what you need to worry about most. What you need to worry about most, generally, are bad guys using this new approach in the cloud era, which is constantly automating scans for misconfiguration vulnerabilities. To the extent that, and I think actually the last time we presented this here, one of the other presenters, I believe it was at this group, was showing live how every few seconds, bad actor bots were examining their infrastructure, looking for misconfigurations. So if you put something on the internet that has an internet addressable endpoint, within minutes, the bad guys have looked at it and have a list of known vulnerabilities. And if you have those, you go in their database for somebody who can then later be hacked, and they prioritize this. So the high profile breaches we've seen in recent years, almost all of them, including the ones with really, really big names on them, if you look at things like DOJ filings, they're generally speaking, almost always, the result of this automated approach. And then the bad guy, when they have their coffee in the morning and are looking at the list, says, oh yeah, I want to go after this, security company. There was actually a cloud security vendor who was breached this way, or bank, or what have you. So the bad actors are using automation to exploit your misconfigurations. And what that means is you really can't respond to them manually. So a little bit about the cloud attack surface. It is complex and ever expanding. So in the days of the data center, you would have infrastructure teams, you would have security teams, you would have usually something along the lines of a change control board that were deciding how the infrastructure should be configured. It was pretty static. Recapitalization cycles might be 3 or even 5 years for these devices that were brought onto the data floor. By data center, I don't mean whether you own the building or not. Co-location is the same. I mean, when you're first laying down infrastructure and then populating it with applications, these things were manually deployed, configured, and maintained. Now, in the cloud era, you truly have software-defined infrastructure, right? Because there are APIs to do things like create networks, create Kubernetes clusters, create serverless functions, create trust relationships between those things. etc. These are API calls. And what happens when you have API calls on all of that is you get an extreme form of dynamism, right? You get constant mutation that you just didn't have in the data center. And occasionally, both at AWS when I was there and now at Fugue, I'll run into somebody who says, oh, no, we control all of that. It's all clamped down. And then we'll point Fugue at it, and they'll find out that actually people are mutating it because it's just, generally speaking, unrealistic that people are going to go 100% of the time through some kind of pipeline and approval process because people have jobs to do and there is pressure for results from management. And results here don't mean security. They mean, if you're a private company or a public company, if you're a commercial entity, that probably means revenue. That probably means top of line growth. And those pressures work against, those pressures combined with the ability to create and modify infrastructure in effectively real time through APIs means that you are actually being exposed to risk through that. So developers, engineers, really now build and modify their own infrastructure environments. This is an inversion. And we're just beginning to deal with the consequences of this inversion. By inversion, I mean in the data center days, it was this slow moving process. You would build out infrastructure and then some of that infrastructure would be assigned to engineers and developers and business units. And now what we see all the time is the business units are building their own infrastructure ad hoc, and in some of our larger customers, there might be 300 different teams doing this or more. And the infrastructure team is just trying to keep track of what's going on. And so this has really, really changed the environment for folks that are concerned with security. And by the way, you're never going to pull the reins on that horse successfully. You might briefly, but it'll be temporary because the competitors are going fast. And the way you go fast is by letting those development groups and those business units move very quickly. And what that means is security folks have to automate. So the best way to do this, in our opinion, is through policy as code. So again, I won't go over this again. We talked about infrastructure teams delivering infrastructure and app teams putting stuff in it. But interestingly, validations and audits in the old bad world, and I'm going to argue, by the way, that cloud is potentially vastly more secure than the data center because we can automate defense too. But in the old days, we really couldn't because we had to do data calls and ask people for their posture and fill out Excel spreadsheets and go through audits that were manual. Keep in mind, the bad guys are scanning every few minutes, every few seconds. The good guys are going through quarterly, biannual, annual audits. All your data is gone by then. So this is largely, you're going to have to do them still for things like, SOC 2 accreditations or NIST or whatever you're doing, but it's not actually helping you very much. And in the data center, there was extremely spotty API coverage for automation, and every data center was a snowflake. Well, in the cloud, you can do policy as code much more effectively because there are APIs on everything. So as developers are creating and modifying their own infrastructure via thorough, complete, and consistent APIs, right? Like you can't call AWS, well, not in most cases, and say, give me some extra APIs because I'm on the security team. You have the same APIs the developers do. That means there's a one-to-one match between what they're able to access and you're able to think about from a security perspective. And therefore, policy as code can be used to automate that process. And that's actually the first, I've been in this business a long time. This is the first time we've been able to do that. So by automating with policy as code, you get accuracy, you get consistency. There's less subjectivity, which is always, in my opinion, good in computing. It's fast and it's scalable. Ross says amen to subjectivity being bad in computing. Yes, thank you. There are plenty of places it's awesome, but computing, you want determinism, you want consistency, and you want consistent results that are the expected result. You want least surprise, right? To use the term that sometimes gets used. But there's another cool thing that Policy as Code does, is it makes the security team tool vendors to the app dev teams and the business units. So Policy as Code is actually going to empower the engineers to own the security of their cloud-based systems, make it repeatable, make it testable, make it shareable, make it scalable and peer-reviewed. So we at Fugue have gone from, you know, being a startup with a relatively small number of customers to now running over 1 billion policy evaluations a day using OPA. I believe we pump more data through OPA than maybe anyone. The reason I say maybe is because folks like Netflix and Pinterest are now using OPA on smaller transactions. But I still think we're pumping more data through. And we've managed that scale with the same size team. So when you think about that, and you think about what it normally takes to do validation and security, you know, validation of environments, audit, and so on, that would be ridiculous, a ridiculous thing to say. Well, guess what? We just parallelize out with our compute infrastructure and we're good. Okay. This is a lot of slides. I'm sorry, folks, but I have to introduce a lot of concepts. I hate slides, but in this case, we just kind of have to go through some, I think, for this to make much sense. So this is really critical to me. So my background is I'm a programmer and a software architect who has been very concerned with security for decades. And the reason I've been very concerned with security is, one, it's really fun and fascinating to me. But two, I worked in a lot of national security kinds of environments. And what we believe at Fugue, and I think OPA is a huge help in this, is what the developer wants is feedback in the same way their compiler or interpreter or linter will tell them if what they're doing is clever or dumb or correct or incorrect. You need that for security as well. And if you do that, your developers will respond. And so OPA is great at providing this. So programming languages, you can express logical functions as code. I don't mean functions with a capital F, you know, Haskell programming. I mean just like operations, right? You can express functions as code, and then compilers and interpreters provide feedback to developers on whether their code is functionally correct. If I try to multiply, I don't know, a floating point value by a string, if I have a halfway decent compiler or interpreter, it will at least warn me that that's probably dumb. But security has never been part of that. And that's where Policy as Code comes in. So with Policy as Code, because your security posture can be expressed as code, the Policy as Code evaluation provides that same kind of feedback to developers on whether their code and systems that will result are going to be correct regarding security. So if I leave port 22 open to world, if you're using Policy as Code, just like I would get an error, you're being dumb with doing that, floating point string multiplication, you're being dumb leaving something vulnerable to the world. And what that does for the security team is it makes you a tool vendor. It makes you a highway builder, not a toll booth operator, because now you're giving your dev teams what they need to fix stuff before you have to get involved. And that makes everyone happy. Okay, let's switch to what is OPA? So OPA is Open Policy Agent. We say here an open standard. We didn't capitalize standard intentionally, but it is becoming a de facto standard for Policy as Code. So it is not a formal standard, that a standards body is behind, but it is a project in Cloud Native Computing Foundation, and we're seeing it take over, frankly. So you should learn it. Whether you use Fugue or not, and if you're worried about security, you should learn OPA. So sponsored by CNCF. Those are the same folks, by the way, who manage Kubernetes. So, pretty respectable group. You can write policy using an easy to learn declarative language called Rego. I don't know why it's called Rego, and I don't know why they gave it a different name than OPA, but the language is called Rego. We at Fugue actually have, as I mentioned earlier, have a bunch of patents on policy as code and language and compiler design around this. And we switched from our own language to OPA. And, you know, that's a tough decision to make. But the reason we did is it's excellent and it's gaining huge traction. And most of the things you could want in policy as code are expressible in Rego. We say here can validate any JSON/YAML. That's my typo or my mess up. It's JSON. It analyzes JSON data structures. Just about everything can be expressed as a JSON data structure. And that's why it can be adopted for a wide variety of use cases. So we use it for analyzing your cloud infrastructure environments, you know, AWS, Azure, GCP configurations. But the most common use case for it is authorizing transactions between microservices in Kubernetes clusters. So if you think about microservice A and microservice B talking to each other, and microservice A says to microservice B, give me the entire customer database. This is where an OPA policy could step in and say, actually, microservice A, you're only qualified to watch, whatever, this particular film. I didn't have a clever film to put in there. I wish I did. All right, a little bit in chat here that I want to respond to. So question, sponsored by Styra. The foundation doesn't sponsor projects per se. Yeah, I believe it is sponsored by Styra. Styra are the startup that is based around it. I have to look. It is a CNCF project. So if I use the word sponsor incorrectly, I apologize. From Minaj, could this be used alongside infrastructure as code? Yes, in fact, I'm going to show you, we have a whole open source project on GitHub that if you're using Terraform, already has a ton of OPA you can use with your infrastructure as code. Yes, it is openpolicyagent.org. Yeah, I'm going to jump away from the chat because it's getting down a little in the weeds. All right. And by the way, the questions I'm seeing on the chat are going to get answered in this presentation. So you can do API governance with it. You can do anything that analyzes a JSON data object, data structure, for validity against policy. And there is a really robust tooling ecosystem, openpolicyagent.org, and I'm going to give you a little bit of a tour around their site as part of this presentation. Has a bunch of tooling. We at Fugue, because we're operating this at massive, massive scale, have built a bunch of open source tooling for it, including Regula, which will validate your Terraform prior to deployment, and Frego, which is the Fugue Rego toolkit. I mentioned the language called Rego for doing better things like breakpoints and debugging and so on. All right, so why is this such a big deal? And I mentioned earlier, we actually wrote our own policy. Actually, it was an infrastructure and policy language that we wrote a whole compiler for and so on. Why did we switch to OPA? What's the big deal about having Open Policy Agent out there gaining all this traction? Well, there is a long history of folks trying to do this sort of thing. And in every case to date, it was either proprietary or some horrible, horrible XML schema. Okay, there were attempts at that. They actually didn't include implementations either. But if you've ever lived through the bad old days of giant XML schemas, you'll know what I mean. But the proprietary ones are the ones that are your real alternatives. So for example, if you are looking at a particular, like Palo Alto's cloud security product, the only way you're going to write policy as code is using a proprietary pseudo language that's baked into that one product. And if you decide to switch to somebody else's cloud security product, you're going to have to use a different proprietary pseudo language. And by pseudo language, I mean one that is not really formally enough defined to understand. These are usually slapdash add-ons. So it's single use case, there's vendor lock-in and risk. There's usually no version control because it's very often stuff you have to use through the GUI or the CLI of the proprietary tool. They're often very inflexible. So OPA is extremely flexible. They really never develop a true ecosystem or community because of the vendor lock-in issues, because of the limitations of these things. There's no portability of rules. So if you go develop all of your policy as code with one vendor and they're using a proprietary expression of that, and the decision is made to switch vendors and you've accumulated 300 rules, well, guess what? You're going to rewrite all those. And they probably won't work the same way in the new environment. And therefore, your engineers are gaining very limited skills. It's really not worth it to the engineers to learn this stuff except their boss told them to, which is literally the worst reason for engineers to do anything, is their boss told them to. The best answer is because they want to. And with OPA, there's the potential for that. So with OPA, you can do all kinds of use cases. It's extremely flexible. It's very, very well thought through. There's really no lock-in and vendor risk. As long as people are doing OPA more and more, and I mentioned Netflix and Pinterest, I'll show you some more on the OPA site. More and more, this is kind of becoming the standard. You can use standard version control, GitHub repos. It is extremely flexible. Simple OPA is really easy, but it extends to any complex scenario that you can apply to a JSON data structure. And trust me, those can get really, really sophisticated and powerful and fancy. It's becoming a robust ecosystem and community. I had the opportunity last year when we were still traveling and doing events to speak at KubeCon at the OPA subgroup. And that room was like not even standing room only. It was absolutely packed out in San Francisco to learn more about OPA. You gain rules portability, right? An OPA rule should evaluate in any valid OPA implementation. So instead of writing locked-in code, you should be able to own your code. And then also, by the way, your engineers are learning something because it's valuable to them, not just because their boss told them to. And that means there becomes, over time, and this is still early for OPA, but it's happening, there becomes a market for employers to find those engineers. All right, this gets to one of the questions in the chat, but before I do that, I feel like I should do another background. So I'm going to stop sharing. And I'm going to stop video for a second while I find a good background. Drew, Sivia, is there anything in chat while I'm looking this up that we didn't cover yet?
Just
Yes.
looks like a question about the applicability of OPA for things like CloudFormation, YAML, etc.
Okay, so yeah, right now, at least with our open source project Regula, we are just covering Terraform. All right, I've got a new background, by the way, so you can start guessing. It's a science fiction movie. We are going to be covering CloudFormation, anything that ultimately can be expressed as JSON. YAML is not supported right now in OPA, to my knowledge. I didn't. Maybe they did a release today that it is, but I don't think so. It's JSON focused. If you've ever worked with actual code that unpacks JSON and YAML, or that works with JSON and YAML, you'll know that JSON is very deterministic, and YAML has some real challenges in interpretation. Any other questions while I've got my background up? Yeah, we don't have a winner yet. So for those not watching, no, it's not mine. I might have to give a clue soon. I got to tell you guys, you have a reputation to live up to now, because when I did similar backgrounds for a group in Silicon Valley, they were, okay, we just got a winner. They didn't get half of the ones you did, and it took them twice as long. So I'm just going to say, if you remember the East Coast, West Coast, hip hop thing, East Coast on backgrounds is winning. All right, I think somebody said Judge Dredd. I kind of wish it was Judge Dredd, but it's not. It's THX 1138. THX 1138 is George Lucas' first real film. It's a science fiction movie. I think it was like 72, something like that. And
It was before my time, so I don't know.
Fair. And it's a sort of 1984-ish dystopian future kind of movie. Gets mixed reviews, but I mean, really stylish, right? Okay, back to the presentation, and I want to make sure we finish on time, and I'm down to 15 minutes here. Sarah, when does my presentation end? I'm being kind of long-winded. Should I hurry up? Well, I'm waiting for Sarah to jump in. You do not need to be doing infrastructure as code to do policy as code, but they work great together. So you can do policy as code against stuff that you built, however you built it, and it will, using a tool like Fugue, it will, in the free version of Fugue, it will go and tell you using OPA, and you can put your own custom rules in whether or not you're meeting policy. Now, if you're doing infrastructure as code, you can use something like Regula that I'll show you briefly, and you can check it before you even deploy it, and you'll catch somewhere between like 20 and 50% of errors prior to deployment. The reason for that is infrastructure as code does not fully describe what's going to happen after you run it. And there's a lot of stuff you care about, you should care about, you need to care about, that you can't, the infrastructure as code, whether it's Terraform or CloudFormation or anything else, just has no information on, because there are side effects in cloud APIs. So you want to do it all the way through, but you don't need to be doing infrastructure as code to do policy as code. You can do policy as code in a few minutes after this conversation tonight. Yeah, so we believe that you should be doing policy as code right now, and it takes priority over any infrastructure as code project. So you need policy as code because the disparate methods used to create and modify cloud-based systems impact your security posture. In other words, if you're operating at any kind of maturity on cloud, you probably have folks who have built stuff lots of different ways. Some might use Terraform, some might use CloudFormation, some might use Bodo scripts, some might use the console, or might have in the past. So anything that only works with infrastructure as code can't solve the problem. You have to have the ability for your policy as code to apply to infrastructure no matter how it was configured. All right, so how to automate cloud security with policy as code across the software development lifecycle. You know, there are more than this number of phases in typical SDLCs. We think the important three kind of broad areas to apply policy as code. And by the way, if you hear a dog in the background, there is a dog in the background, so I apologize for any noise. During the design phase, you can validate infrastructure as code with policy as code to find a certain number of violations early. As I mentioned, it's going to be incomplete. One just simple example of that is when you build a VPC in AWS, you get as a wonderful gift from AWS a default security group, which is dangerous because it allows egress on all ports. So you're not going to be able to detect that in your Terraform or CloudFormation template, most likely, except in very unusual circumstances. But you're going to immediately detect that with policy as code when you compare it to the configuration of what happened when you ran that infrastructure as code. So you should be doing this. It is important. It will save you money and time. It will make your developers much better and your engineers at getting infrastructure as code safe and secure, but it is very incomplete. So next is during deployment, where you can prevent deploying misconfigured infrastructure through CI/CD integration. So here what we're talking about is, if you include OPA in your CI/CD pipeline, so for example, you've run OPA or not on your source code for your infrastructure as code, and then you get to building in dev, right? That should be your first step, is some kind of dev environment. You can build into the CI/CD pipeline an OPA check that looks after the thing has run and tells you, no, these are errors. And that can be set as something that is a build fail as you get further down the SDLC, so that it cannot be deployed to stage or prod unless those OPA checks pass. So you can use it at design time. You can then use it at deploy time. But then finally, you really have to use it at enforcement time too. So once you've built something, it's not good enough that when it was built, it was good. You need to know every minute of every day if it's still good. So you have to continuously scan the infrastructure and the values and the configuration of that infrastructure against those same rules. And this is why it's so important to not have different ways of expressing policy at different stages of the life cycle, because they will be inconsistent. So if you're using like a Terraform linter during design time, by the way, they call them linters, but they're not linters. They're just kind of trivial checks. That's going to give you one set of information. And then if you're using a proprietary language at enforcement time, it's going to have a different interpretation of policy. So this is where OPA is really, really cool. All right. I'm going to dig into this. If you saw our last presentation, this typing the terminal was my favorite way, but we're just going to be talking and showing information and where you can dig in. All right, this is actually Fugue's console, and the reason I'm starting here is to show you how OPA can be used against running infrastructure. So what I'm showing here is, what region is this? This is US West 2. I've asked Fugue, running a bunch of OPA rules, to go examine that infrastructure. And you'll see a bunch of stuff here is now painted red. Those are things that failed OPA policy evaluations. So if we look at this VPC network, we're also going to show you just like everything about that infrastructure. But you can see here, I mentioned this earlier, VPC default security group should restrict all traffic, right? That's in CI's benchmark. You should not leave that thing turned on, but it's probably sitting out there in your infrastructure. So what I would recommend, and what we see every day, is the place to start with policy as code is with a free tool like this, where, and I'm not aware of any others that do it, but I don't want to make it too pitchy, but this is what we can do for you, okay, for free. You can point it at your infrastructure, and we will show you using OPA everywhere your infrastructure is failing OPA policy checks. So here on this load balancer, access logging should be enabled. Listener source protocols should not be set to unencrypted protocols. Cross-zone load balancing should be enabled. We map that to like compliance families, but all this is being done with OPA. Okay, so all of our rules that we bake into our product are in OPA, and you can add your own in Fugue as well. I'm going to come back to this, but I hope this makes sense, and I hope you can see that you don't need infrastructure as code to do policy as code, because this stuff could be built any which way you choose. You just point the product, the tool at that infrastructure, and it will tell you where you're failing these policy checks. Now, these ones I've shown you are the ones we include that are compliance framework based, but you can write your own and check them out. All right, I'm gonna, so I just wanted to kind of brief you on that, and we'll come back to it if we have time. Openpolicyagent.org. This is the website for OPA. You can see here, created by Styra. They are awesome. They are, by the way, pointed at a completely different problem space than Fugue is. And we're extremely friendly with each other. They're the ones who invited us out to KubeCon. They are mostly concerned with transactions inside of Kubernetes, which is probably the dominant use case for OPA. But openpolicyagent.org, let's get past the marketing speak and get to, where is their link to, actually, I do want to talk about one thing here. There's a lot of architectural flexibility in how you deploy OPA. There are two deployment modes. One is a daemon. So you might host that in a service, like a sidecar in Kubernetes, or just a microservice endpoint, and you can call it over the network to check stuff. But if you've built distributed systems, you know that you would do that if you're worried about scale, but you know performance is going to be terrible compared to having it embedded as a library. So it's also embedded as a library. You can use it either way. So it can cover lots and lots and lots of use cases, depending on whether you're worried about scale or you're worried about latency more, will inform your decisions there. There's lots of good tooling. There's a Rego playground. There's really good support in VS Code, which I'll show you in a second. There's a CLI and a REPL. They're pretty good. The REPL's pretty good, but we actually went and built our own REPL because we wanted some other stuff that wasn't in there because we write so much of this. So, where is the GitHub?
Josh?
Oh, here we go. Yes.
You do have a couple of questions in the chat that I'm not sure you answered. Joe asks, is OPA static code analysis for CFN, Terraform, or runtime validation checks?
Not really. And I think there's a good reason for that. So if you're not familiar with this, static evaluation is a kind of analysis you perform against source code to try to find in that source code, errors that could be prevented, I guess is a simple way to put it. So here's the problem. Terraform and CloudFormation are not real languages. They have no formal specification. It is impossible to do proper static analysis of code in either of those things. They're full of side effects. They are really not languages at all. They are configuration files. So what we do with this project, Regula, which you can get on GitHub, github.com/fugue/regula, it's fully open sourced. We will evaluate the plan file that is generated by a Terraform configuration file to look for errors, okay, using OPA. And this is all, you can just download it now. You can see all these, we're doing it for, AWS, GCP, Azure, come contribute, come write some OPA. And this will do evaluation of Terraform against AWS, GCP, and Azure prior to deployment to try to catch errors. What we have found is you really cannot perform static analysis. We're not using the source code. The source code is almost meaningless. What matters, because it's not a real, like, language designers did not come up with these products. They're config files. So when you get to the plan file stage is when it starts telling you in a more deterministic way what's going to happen, and therefore we can perform some analysis. Even there, as compared to this, where we're analyzing the results, you can only catch, and this is all we do, by the way, is this kind of, deep introspection of cloud infrastructure, maybe 20, 30%, because the plan file, even though that is more deterministic, is not complete because of API side effects. So if you want to drill into that deeper later, we can. It's almost 7 o'clock.
So I just want to mention one more thing, that there are some tools out there today that people are developing that does static code analysis, which is just doing some benchmarking against some benchmark. The advantage of that is that simply that you can catch things earlier before you go too further into deployment and to the right side of the spectrum.
Yeah,
there
so we
are runtime tools. So my question is a little bit more deeper than this. There are runtime tools like AWS provides, Security Hub and a bunch of other tools, as well as Evident.io and Dome9 provide the tools for runtime inspection. So my question is, if we were to pick a tool for each one of these problems, where exactly does OPA fit? While we have all of these other tools.
Yeah, so we're in all the ones you mentioned, it doesn't, and I think that's a really bad mistake. So back first to static analysis. Anything that is claiming to do static analysis against these source code files isn't. What they're probably doing is what Regula, and by the way, with Fugue's Regula, we catch things as early as anyone can. We catch them prior to deployment. But the point I was trying to make is static analysis is the incorrect term to use here, and maybe I'm being too pedantic and geeky. But what you can do and what Regula does, and we have by far the most complete form of this of anyone, and it's totally free and open source, is we use OPA to analyze what Terraform is going to produce prior to it producing it. We're adding CloudFormation as well, but that's more challenging because it's a black box and there's no equivalent of a plan file. So everything that any of those less complete tools can do for analyzing source code, they're probably analyzing the plan file, which is how HashiCorp does it with their proprietary version called Sentinel. They're probably analyzing the plan file because the source code files are just totally inadequate to the problem space. So are there, well, Evident's gone. Evident is now part of Palo Alto and they retired the entire product. They bought 2 companies and Evident is now history. So, but it's part of, well, it was purchased by Palo Alto as part of Prisma. So this is actually kind of a central point to what I'm trying to say here. If you have one set of policies for your development stage written in one form, and another set of policies for your runtime written in another language, they will not agree. And that is why OPA becomes important and why we've implemented it all the way through the SDLC. So Security Hub does not use OPA. Dome 9 does not use OPA. Sentinel does not use OPA. And therefore, you're going to have different rules at each stage of the SDLC. And those rules will not agree, and you have to maintain them all separately. So this is why OPA is so exciting, because now you can have a single rule that you can apply to source code, although it's actually more like linked code, and with something like Regula. And that same rule can be used in the CI/CD pipeline to check whether or not something should be allowed to be deployed. And then that same rule can be used for compliance monitoring in the runtime. Does that make sense? Am I answering that?
Yeah, I mean, I just have to see it working. Like, do you have something working? Like, can you show where you deploy something and it's catching something live?
Right here. That's what this is. So what this is showing you in a visualization, so to be clear, these are VPC networks. Over here is the internet. I've got a bunch of, this visualization is part of how we like to interpret it so you can do discovery. So over here is the internet going through different VPCs. Here's US East 2 into some S3 buckets. Okay, well, let's take a look at why this S3 bucket is failing. And by the way, this is running constantly live. So when I look at this, I can see that bucket versioning and lifecycle policies should be enabled. I can see that bucket policies should only allow requests that use HTTPS. Now, using Regula, this same rule can be used against the Terraform source code. It's not the source code, it's the plan file that the source code produces in the plan step, because that's where you actually get something somewhat deterministic. So it's gonna catch, actually in this case, it's gonna catch all 3 of these, but that same OPA rule can be used in all 3. But this is live and running.
Now, in this case, the infrastructure is already deployed. And if they are not actually built from Terraform, and now that you catch it, how do you remediate?
Well, you know, that's a big question. So how do you, let me echo back and see if I understood the question properly. So in this case, we have errors that made it all the way into production. We didn't catch it up front in the Terraform stage. We weren't using Regula. We weren't using CI/CD pipeline, including OPA. And so it's made it to production. Now, how do we remediate? It depends on the type of error. It depends on your process by which you create and manage infrastructure. So I would argue in a scenario where you are using, for example, Terraform or CloudFormation, that the correct way to remediate is to get the error information, just like this. You know, I'm showing it in a GUI. You can get all this via API with, at least with us, and go back to your template, to your config file for Terraform or CloudFormation, fix it and modify it. The reason I say that's the best way to do it is if you're using infrastructure as code and then you're modifying stuff after it's deployed, your infrastructure as code is no longer valid. It is no longer expressing what is in production. There's a delta between the two. And I think that's a mistake. So is that what you're asking, or did I answer the wrong question?
No, I understand. Good, good. So pretty much the remediation in this case really is pretty much manual. There's no way to automate.
So Fugue does a bunch of stuff with auto remediation, but that's not really the topic tonight. I'd be happy to stay late or take another call to show you how we actually have 100% self-healing full auto remediation of infrastructure once it's in a good state. But that gets off the topic of OPA. OPA is not going to auto remediate your infrastructure. It is going to prevent you from making errors once you implement it, if implemented well. And it will tell you after the fact where you have errors. But remediation is, and like getting, actually pretty soon here, Drew, can I jump the gun on the masterclass we're gonna do? Can I announce it early?
Yes.
Absolutely, yep.
All right, so we're gonna do a masterclass on how to get your infrastructure into compliance. And I'm not gonna be teaching this one. I'm gonna be the host, but we're gonna have a true expert on this who does it all day long, every day, on how to go from out of compliance, out of policy infrastructure to in policy infrastructure. And it's gonna be a very deep dive, and you're gonna be able to ask any questions you want. So we'll be doing that. Well, I don't think we have a date yet. I think we decided to do it today, but we'll certainly share it with the group. All right, I want to do one more background. I also want to make sure.
You're good on time. Don't worry.
Okay, cool, cool. Well, I'm here as long as folks want to hang. I'm going to go off video to get a background, and give me one sec. Sivia, fire off, or Drew, fire off any questions that I missed.
Okay, so one of the questions was, how are the policies governed?
Oh, that's a good one. That is a good one. What's going on here?
Your background is up.
Okay, cool. All right, a little on my background. This is a famous keyboard. I'm going to move to the side here so you can see it. It's pretty old, but it's pretty famous. And you can win by telling me, no, not APL, not PDP. You can win by saying the name of the company. The company's no longer around. They were really short-lived, and they made super innovative computers. But this particular keyboard has a nickname too. Oh, Brent says he knows, but he's not going to say. All right, I'll start to give you a little bit of more hints. It was a Boston company in the 80s. This one might be too hard. See, I came into this because you guys just tore through my backgrounds last time. Bell Labs, Digital, nope, not DEC, not DEC. It's weirder than that. You guys tore through my backgrounds last time, so I was like, I better come with some tough ones. Wang, no. Okay, I'm going to call it on this one because I think you would know if you knew, and we would know by now. This is not Prime, not Data General. You guys are just guessing now. this is, I'm going to call it this. I'm going to put up another background, so you'll get another shot right now. But this is from a company called Symbolics, and Symbolics made Lisp computers. So these were computers that ran Lisp, the language, as their operating system, and actually had processor units based on Lisp. And the keyboard is now these days referred to as the Space Cadet keyboard, because it has just like Emacs people could use this, right? Like it's so many modifier keys. Okay, that didn't go so well. All right, let me try a different one. Let's switch it up to gaming. All right, here's a gaming one.
Hey, Josh, while people are guessing, Joe had a question about the scope of OPA for AWS IAM.
Oh man, we do incredibly complex stuff with IAM with OPA. Yeah, it's not Final Fantasy. So yeah, it works great for that. In fact, briefly, I'm going to show you some source code in OPA, and I'll show you some IAM source code in OPA. But it's incredibly powerful. It's so we had a Final Fantasy and Final Fantasy IX. It's none of those. This is pretty recent. This is only a few years old, this game.
So the one that we were going to talk about was how are the policies governed?
Oh, sorry. The policies can be governed however you govern any source code. So we use GitHub. And if you go to github.com/fugue/regula, you can download a big library of open policy agent policies that we just manage there on GitHub. And you should contribute to it and write some cool policies. All right, man, I'm just missing tonight. Let's see if I can find one that people know. So the answer to this one is Nier Automata. So I went from too easy to too hard. Let's do another video game. Let's do this one. It's not Rocket League. Oh man, I went down.
I think folks who were here at the last one might be able to guess.
We're getting a lot of not gamers here. OPA Racer, OPA Racer.
Oh.
No. All right, I think we're gonna move on because I want to make sure I can show you a little more OPA stuff. All right, I'm gonna go back to sharing my screen. But keep guessing.
Yeah, I'll keep an eye out on what the guesses are. And
all right, I'm just going to jump in and show you some OPA. There's some Rego. This is OPA code. So this is from that regular project. You know, if you go to, where did I put my web browser? Here, this regular project, all these rules. I actually need to update my local Git repo because we have a bunch more rules in here. But you can see here for like AWS, we've got stuff for EBS. We have stuff for IAM. IAM user attached policies. IAM policies should not be attached directly to users. So you can analyze any of this using OPA. I'm going to start with a really simple one just to show you how easy it is to get going. So in this case, we're just saying VPC security groups should not permit unrestricted access from the internet to 3389. Okay. Now in Regula, Fugue has put together a bunch of rules and libraries for you for convenience. So here we're saying in rules.security-group ingress anywhere RDP, import, oh, I'm sorry, this is the package of this actual code, but we're going to import data Fugue Regula AWS security group. So one of the cool things about OPA is it's a real language. It's not a Turing complete language. You're not going to write, programs in this to play, you're not going to write games in it or whatever. But what it does do are things like have comments and have import statements. And I'm importing this as a security group library. Okay, so when I refer to security group library, I'm going to then call that later. So the resource type I'm looking for, and again, this is all declarative, right? You're not going to see any actual imperative code in here. You're not going to see for loops and stuff like that. So I'm looking at resource type AWS security group. I'm looking for the controls. Well, I'm not looking for. I'm saying the controls that are implemented here are CIS 4.2 and our own internal regula. This is actually just for helping you map to existent rule sets and understand when you get a failure, what you're failing. So here what we're saying is if this rule fails, you're failing CIS 4-2. Now this is, so all this is just some, packaging code up here, really. It's just getting your imports, naming the package, asserting a couple of variables, which are immutables in this case. Now we're getting to logic. So we're going to say default deny equal false. So what we mean here is, and this is a double negative, right? The default denial state is not to deny, unless our input ingress of underscore, which is saying any ingress from a security group rule, blocks on 3389. So what we're saying here is approve a security group unless it allows 3389 to internet. Similar, this is a super simple one. Is are your KMS rules rotating? So KMS key is the resource type. We've mapped it to CIS here. The default allow here is false. So here we're saying don't allow unless the allow input enable key rotation equals true. So some of these are extremely simple to write. Looks like we've got some questions. Can't AWS config do this as well? No, it can't. AWS config is much more limited in scope than well, one, it won't examine Terraform plan files. So with Regula, you can examine, and this is, everything I'm showing you is open source. I'm not trying to sell you a product. I'm trying to show you an open source technology. And no, config can't do this. Config can only operate against the runtime environment. It doesn't use OPA, and you have to write your own rules in horrible JSON syntax, and then maybe write remediations in Python or something like that. But this is that's a much kludgier way to go about it. So somebody said, my understanding is AWS config plus security hub can show these CIS violations. So if we have a tool that auto remediates, then where does this tool fit? Boy, okay, you can cobble together something. Actually, you can't do anything I'm showing you right now using security hub and config. 0% of what I'm showing you right now, because we're operating now against this. And no, you can't do AWS config and a custom Lambda. No, what I'm showing you now is going to operate against the Terraform plan file. This is pre-deployment. Config cannot do that. Lambdas will not help you there. You're on your own from AWS perspective. So, but this same rule that I can apply to the Terraform plan file can be loaded into Fugue for the runtime. Okay, so so if you were to try to cobble something like this together with a bunch of tools, Joe, write unit tests for CloudFormation. These are kind of like unit tests for Terraform. Right now, this is based on Terraform plan files. We will support CloudFormation soon. Again, this is for free and open source forever. You can just go to GitHub and check it out if you're using Terraform. So the beauty of this, though, and I'm seeing from the chat that I'm failing to communicate this. If you use AWS config or Dome 9 or anything else, then Fugue in the runtime, and by the way, Fugue has a forever free version, the OPA won't work. You have to rewrite the rule in whatever that proprietary language is. So config has its own proprietary language. Dome 9 has its own proprietary language. And whatever you're using for pre-deployment probably has a different proprietary language, although it might be a free and open source one, it is probably not a true language. OPA is vastly more powerful than any of those things, and that's why it's so cool, because you can use the same rule through the entire SDLC. Here I'm showing you pre-deployment, but here I'm showing you post-deployment using the same rules. So somebody said, which Fugue is free forever? It's called Developer, and you can use it for free forever up to, I think it's 1,500 cloud resources. If you're using us at enterprise scale, we do ask you to pay for it. But if you're using us, okay, so this is, if you're using us at like engineer scale, free forever, and it's a SaaS and it doesn't install anything in your environment or any of that stuff. So somebody, Joe's saying, got it. Basically, OPA is like unit tests and integration tests. That's pretty good, actually. You can think of the Regulus side, the pre-deployment, as a bit like unit tests, right? But when you get to post-deployment and you're looking at how those things actually come in and fit together, because very likely this VPC network was born in a different Terraform template than this S3 bucket. Right? It's unlikely those were in the same Terraform plan. But when they come together, then you can use OPA to do that integration test to see if everything's still secure. And then you can use OPA to constantly monitor it to make sure it stays correct and secure. I do want to show, I'm trying to remember which one it was. Yeah, so here's a more sophisticated, so I showed you some really simple examples because you should not be afraid of this technology. I don't care if you've never written programs before. To do simple stuff is really simple. But the beauty of OPA is you can also do really complex and sophisticated stuff. So you're not learning something that's boxed in, like somebody mentioned Dome 9. They have extremely limited features here, and it's all proprietary. Well, with OPA, or AWS config is the same, honestly. They can't do anything close to this level of sophistication. But with OPA, you can do easy stuff easily, but then you can get into very deep stuff where you are looking at things like the relationships of IAM policies versus principles and what permissions those policies grant, etc. So I'm pitching you on OPA, not Fugue. We love it and believe in it, and it's baked into the product, and think it's great. Here's one more example. So here we're checking that VPC flow logging should be enabled. That's another one you often can't check in source code. I mean, in this case, we're checking it in source code, but in some environments, the VPC flow log happens from a different plan file. So here we can look at the policy, resource VPCs, not is valid, Fugue deny resource, that's the policy statement based on flow logs on that VPC ID. So you can do the prosaic, you can do the sublime, and you can do in between all the way through the life cycle. Yes, Gail got Final Fantasy VII. That is correct. My background is Final Fantasy VII. All right. Well, I think, let me just check my deck. Drew's going to yell at me and Sylvia's going to yell at me. Oh, right. I just want to put up some resources. Here's the stuff I was showing you. I didn't even get to show you Frego. I'll show it to you just briefly since people don't seem super time sensitive. I showed you Regula. We also have this project called Frego, which is the Fugue Rego toolkit. This is also just completely open source. And what it will allow you to do is like debugging and breakpoints and things like that that are not covered in standard OPA tools. So it makes it much easier. You can imagine, I mean, I'm showing you in Regula, we have what, like dozens of these rules. In production Fugue, in the full version of the product, we have hundreds and hundreds of these things. So we write a ton of Rego, and therefore we made this toolkit for ourselves that makes it easier to write Rego. And you can get that off GitHub too. It's github.com/fugue/Frego. And I'll go back to our links, and there they are. Any other questions? That's all I had to show you today.
to mention, Josh, someone asked how to configure OPA checks against AWS runtime. I wasn't sure if you already got that.
I didn't see that. Thank you. If by what you mean, if what you mean is, let me use my words properly. I'll just show you quickly how you can check OPA against a whole cloud runtime. So this is just fugue.co. You can sign up for developer. I don't know of a way, like OPA out of the box doesn't do that, but Fugue free forever developer version does do that. And I'll just show you what that looks like. So, and this could all be done via API as well, but we will instead just do it visually to make it easier. I can include all the Amazon regions. I'm going to include all the resource types. We have OPA rules against hundreds and hundreds of resource types. So, but I'm going to just use the defaults to speed this up. I'm going to pass in an IAM ARN. That's all you need to do this, is to have an ARN to an IAM role. And you can use the default security audit role that ships with every AWS account. And then this is where in Fugue you can select which OPA rules. So we support CIS, GDPR, HIPAA, NIST, PCI, SOC 2, ISO, Fugue best practices, which if when you saw my last demo about where I'm breaking in and stealing data, Fugue best practices, none of these frameworks actually would protect you from that kind of hack that I did last time, but Fugue best practices will. And then now there are CIS controls as well. I'm just going to select all of them. So you can see here, I've got 150 or so resource types. I'm running against all regions of AWS. And I'm checking all of these compliance families. This is another place where somebody's talking about Security Hub and config. They don't have anything like this in terms of the ability to actually check. And what they do have is all proprietary, not OPA based. So that's all you do. And then in a minute here, if we're still online, I'll show that to you. Right now, you can see it's generating that. And in a minute here, I'll get a full report of all that. Any other questions for me?
There was one, and you may have answered it, but what tool are you using? The one with the UI and the diagram? Oh,
that's the product that we make at Fugue. So it's fugue.co. That's our product. It's a SaaS. You can sign up, and like I said, there's a developer version. We have customers like SAP that have massive environments. Well, we charge them money. But if you want to just check out your environment, we do that part for free up to a certain scale, and we'll draw these diagrams for you. We'll map all those OPA rules. Oh, by the way, let me just show you in here how you can add OPA rules in Fugue. And I'm going to show you in the GUI, but you can also do this via API calls. So here I'm doing it in the GUI. This is just Rego. This is just an OPA rule. And you can point us to that source code through an API if you want to load a bunch of custom code in too. So unlike things like config or Security Hub or Dome9, they all have the proprietary languages. This is just OPA. And you can add that rule in, and that will show up as part of the custom rules in our product for you. So that's going to take another minute to finish running. Let's do one more background while that's going. I'm going to try, this is not a gamer group. Last time we had a lot of gamers in this group. I'm going to try, okay, I'm going to stop my video. I'm going to try another history of computing one.
And is it okay if people have questions, they can unmute and ask them, or do you want to still have them just in the chat? Since
me?
No,
yeah,
they can.
Go for it.
Okay.
Yeah.
All right.
Oh man, Bill Mitchell, bang. Yeah, that's a cray one. One of the coolest computers ever made. And if you, so this thing here, with the bench around it, Slack's doing this weird finger cutting off thing. This is actually a bench you can sit on around this computer. And it's got this tower, and inside that tower is a liquid cooling system. And this is, I think, early 60s? Central heating, yes. Bill Mitchell said central heating. And if you look inside of one of these, this is back when they would actually hand solder connecting wires between circuit boards. It didn't have like a CPU chip. This thing is the central processing unit and is made of board after board after board after board. Just really, really cool stuff. All right, well, I'm glad that one resonated. I'm gonna go ahead and share screen and we'll go back and show you briefly where we ended up with that. Oh, it's still building. All right, well, that's what I had for you today. I hope this was helpful, and feel free to reach out. I'm just Josh at Fugue. Oh, it finished. So that thing I just started a minute ago is done now. And here you can see we've covered a bunch of regions. A bunch of them I don't have stuff in. But yeah, here's all these OPA evaluations against my RDS database. Let's see what's wrong with my RDS database. I don't have multiple availability zones. I should have encryption turned on. By the way, I'm not showing you like Fugue production systems. Our systems are super secure. Excuse me. I'm showing you my demonstration environments for Fugue to point out failures. So yeah, with KMS keys, and we can do all kinds of fancy stuff with OPA. So we can tell you, that's an interesting, relationship there. Is your RDS instance not just encrypted, but encrypted with KMS keys? We can look for all those things using OPA. But that's how the original question was: how do we run OPA against the runtime? Just go to. We've done all the work for you. You can always do something yourself and hand roll it. But there's a lot to it. So. All right, well, I'm going to turn it back over to you, Sarah.
Thanks, Josh. Hopefully it's not going to be too loud. It's like it started raining very heavily here. Awesome. Here, oh, there we go. Thank you so much, Josh.
Thank you. And the last thing I'll say to the whole group before I just turn it back over is this is one of the most engaging groups to talk to, and I love it. And we look forward to coming back, and you guys are just a lot of fun. So thank you.
Yeah, definitely. I mean, we're not gonna, kick you out right now, right away. If anything, I was gonna ask before we do the raffles, what are some topics that people in the audience or you yourself might be interested in hearing in the future? Because I'd love to have you back, and I'd rather get something in the works now that we have some people in the audience. If you want to just put some topics in the chat, and if Josh, may or may not want to talk about them, I mean, I think that'd be great. And if not, you and Sivi and I can discuss after the fact. In the meantime, while people maybe put some topics in the chat.
I'm looking at Bill's.
Yeah.
Bill and I need to meet sometime. Yeah.
Yeah. We can have a collaboration. I was gonna mention, and I'm actually taking this from Christina before she leaves. She can fact check me. For the first raffle, it's gonna be for $25 of AWS credit, promotional credit. Does anyone, and you could put it in the chat, does anyone know what Amazon's name was going to be before they decided Amazon?
Uncle Jeff Enterprises?
No. Christina knows. She's the one who let me come or taught me this. I did not know. And it's okay if you Google this. I'm not going to hold it against you. No, it was not S3, not Big Brother. Yeah, it was Cadabra Inc. Awesome, Hashish. Okay. So there we go. Yeah, it was Cadabra. They the reason he did not the reason he ended up choosing a different name was because it sounded too close to cadaver. So they didn't want that. But because they still wanted something, obviously, like for the Amazon River, you know, it's so large, it's so prosperous, but also they wanted something, you know, back in the day, whenever you would look up in the search engines, it was usually alphabetical, so Amazon would also show up first. So that's interesting stuff. Ashish, I'm going to be sending you my, yeah, yeah, cadabra, like abracadabra. Ashish, I'm going to be sending you my email address. Make sure you email me or save the email address before you log off. That way you can email me and I'll send you over the link or the promo code. Awesome. And I was going to ask Josh. We've been giving the speakers $50 worth of credit. But if you aren't going to use it or if you don't want it, you can always offer to raffle it off to the audience. If not, we have one more $25 raffle.
Go ahead and raffle it to the audience. I'm feeling generous.
Generous. Yes. Okay, so okay. Because you were the amazing presenter today. If you could give me a number, and I'm gonna just go ahead and choose someone that way. So I did this last time, but it was a little more work. So,
Okay,
Josh,
so like a number between what and what, and I'll text it to you.
between 1 and 33. Ooh, okay. Wait, so Chuba, you got it. Oh no. I was just gonna count down the list on the first one, but on the second one, I should have explained the options a little better. But Chuba, are you there? Chuba? Okay, he might. Okay, he is here. So I'm gonna be sending you my my email address. So this one was for the $50 one. So just make sure you email me. Save the message because last time people didn't email me. So definitely email me. And now, Josh, if you wanna just text me another number and everyone can guess in the chat and we could do it the other way. The number was 9, the previous one.
Okay, so you want me to send you another number?
Yeah. I did it a different way instead of people guessing it. Okay, so here's another number. So everyone can just put it in the chat and whoever has the closest number. That's odd. And we have a question in the chat for you, Josh. Can OPA help with me figuring out, which the IAM users have access to which assets?
Yes. And the reason I'm hesitant is I'd have to look at the APIs available for individual users. Certainly policies and assets. We do that all day long. I'm not quite sure what the API response looks like in terms of understanding which users have access to which policies through which roles. But we can definitely, if you're using roles properly, OPA can definitely tell you if your IAM policy to role to asset, and it's not just asset, right? Like that's one of the reasons we're going to do the masterclass on IAM security. It's really permissions on assets, right? Like EC2 alone has almost 400 IAM permissions. So, but yes, you can introspect like everything about an IAM policy. You can map it to the role, and you can map it to the resources that are associated with it, et cetera.
Awesome. Hopefully that answered your question. Yeah. Okay. So, yep. Thanks, AB. Okay. Well then, I mean, if anyone has any other questions, you know, don't let me hold you guys up. We're not in any rush. I think for me too, Mina. The thunder is going crazy over here.
I wish we were getting that storm. It's still hot and muggy in Frederick.
Yeah. Okay, well, if no one has any questions, I mean, those who want to stick around and network are definitely free to do so for like the next, like, I don't know, 10 minutes. And I'm going to be putting in my, I'm going to be putting in my LinkedIn in the chat room. That way, those who want to connect can connect with me if you'd like, ask me any questions. 1 second. And definitely subscribe. We're going to be having, I'm going to be sending out in the thank you email the link for the YouTube recording. Okay. And here we go.
For Josh.
Well, Ashish, do you have a question?
Yes.
Okay.
So Josh, I mean, when you were showing us running the checks against the AWS runtime environment using Fugue, so you selected some of the like CIS benchmarks, best practices, and everything. So does OPA has its own rules as well, like predefined rules for all these resources, or it's using the CIS benchmarks to evaluate the resources?
Actually, those are OPA doesn't. They call it OPA, like OPA, but they
Yes.
they don't include any rules. So that's where Regula comes.
Okay,
in.
it's just the framework. Okay.
It's a daemon or a library, right? It's like a runtime with a language. But the rules, you know, again, you're welcome to use Fugue, but Regula is just out there on GitHub. You don't have to use Fugue to use Regula. And Regula is a partial implementation of CIS. And we keep adding to it. We intend to, you know, flesh it out to full CIS and maybe some other things too. And you can contribute to it. So those rules are there on GitHub, github.com/fugue/regula. And you can read all the OPA rules that we've put out there in for CIS there. Now, Fugue itself has tons and tons of rules, but those are not published open source because that's, you know, a lot of what we do for a living. So.
Got it. Thanks.
Yeah, Helga says, OPA is what you say when you lift your stein. About to take a sip. OPA. You know, they really, and I'm like deeply curmudgeonly. Just something about me, like I'm very, very skeptical. I've been a professional programmer since 1990. And so for what it's worth, I have a very high view of OPA. I think they've done a very, very excellent job. And the language is expressive, it's powerful, it's easy to do simple things, and it is possible to do extremely complex things. And that is about as high praise, in my view, as you can give a language, right? You shouldn't have to learn a ton to do basic stuff, but you should also never run out of what you can do. And I think they've just done an awesome job. Bill says, OPA equals grandfather in German. As the father of a 24-year-old, I'm very glad to say I am not yet a grandfather. although I look like one. How does it compare to a rules engine like iLog? So, similar in ways. I have bumped into iLog, but I'm not intimately familiar with it. So I will never BS you. So I'm familiar with numerous other rules engines. So I don't know iLog well, and so I don't know if what I'm about to say applies to iLog. But generally speaking, rules engines, in my experience, are more concerned with verbs than nouns. By which I mean they're more concerned with measuring state over time. OPA is declarative and it operates against a single in-memory JSON data structure. So the way I think of OPA is, and Rego, is more like a query language than a rules engine. There's no like cascade of logic in OPA. There are approvals, disapprovals, you can have other outcomes, but it's really like a predicate or a query more than a rules engine. But again, I don't know iLog, so not trying to overstate my my knowledge of iLog, which is almost none. All right, well, it kind of looks like we're winding down. I'll hang out for a few more minutes in case anyone has another question. I'm gonna go off video for a second.
And everyone, I wanted to ask the attendees and whoever's here tonight, if your company's hiring, if you wanted to maybe, share that with the group either via chat or kind of mention something about it, or if you're looking for a job, and if you want to introduce yourself to the community, I mean, definitely go ahead. I'll kind of start. My name is Sarah Morales. I've been organizing this group since about February of last year. Brent's been helping me. I am considered a co-founder because I showed up 3 hours to the first event, 3 hours early to the first event. So, ever since day one, I've been up and at it with this group. I love the people, I love the community, I enjoy security, and I like learning what I can from all the presenters who come. We are still looking for some more organizers. So if anyone's interested in just volunteering and helping out, that'd be great. I'll send out more information in the thank you email. And I actually just recently got a job about 2 months ago as a support engineer at AWS, very recently, but obviously they let me still do the group, so that was really nice. Everything I do is just purely from being passionate about this stuff. And Amazon is hiring, but there's so many roles that it's really good to just go onto their job site. Thanks everyone. Thanks for the congratulations. It's been a rough 2 months, but it's been amazing each step of the way. I'm actually starting on a security team next week, so that'll be very interesting. And maybe I can speak more on what we're all learning here. And if anyone else wants to mention that they're looking or their company is hiring.
There was another question in chat. I don't know if you saw it. Do you see many people using Chef in spec moving to OPA for infra-related compliance from a security specific level? I guess that's for Josh.
Yeah, the short answer is yes. And it's interesting to me because when I was speaking at KubeCon, one of the other presenters was from Chef. So I think folks are starting to see the writing on the wall might be too strong, but and they weren't presenting a replacement for InSpec, right? I don't have any reason to think that they're considering such a thing. But it's interesting to me that folks at Chef are now starting to use OPA for some of this stuff and presenting in the OPA group. So personally, and this is purely my opinion, I think proprietary policy as code frameworks are gonna die, all of them. It's a question of when, not if, because the history of the industry tells us once there is a de facto, and by the way, I think de facto standards are almost always better than standards, unless they're, you need to go through a de facto standard phase to get to a good standard, because we know what it looks like when standards bodies design the standards. They need to adopt the standards. But I think, yes, people are leaving InSpec, people are leaving HashiCorp Sentinel, people are leaving, these proprietary expressions in order to go to OPA because it's open and it's really powerful and it's really good.
Okay, awesome. Hopefully that that answered your question, Wing. Did anyone else want to either ask any more questions, reach out to the rest of us? Because if not, I can go ahead and stop recording now, and we could call it an end to a great night. Going once, going twice. And I hope everyone has a great rest of their night, great rest of the week, and I look forward to seeing you hopefully at some of the future events.
Thanks, Sarah.
Thanks, Sarah. Thanks,
guys.
everyone.
Everybody.
See you, everyone.